Adhesives are used in many high-tech industrial sectors as well as in the production of consumer goods. They're found in everything from aircraft, automobiles, and electronics to labels, furniture, shoes, and many other products and devices. Here at Henkel, we run our products through an array of tests that help determine which adhesive solutions are right for our customers, allow for quality control at every step of product design and manufacture, and provide data that describe the material characteristics of our products. Today we're going to show you 5 of the most common tests we use to evaluate an adhesive, starting with shear strength. Shear strength is the ability of a material to resist lateral forces that cause the internal structure of the material to slide against itself. Adhesive shear strength tests are important for characterizing the structural integrity of a bond between two surfaces. One standard method for shear strength testing calls for the bonding of 2 test specimens overlapped by a specified area. The assembly is secured in a mechanical properties tester and is pulled in shear until failure. We record the load at breakpoint and calculate the corresponding shear stress. This is important because if a material fails at lower strengths, it may not be suitable for some applications. Here we illustrate one of the many advantages to using adhesives over mechanical fasteners. Rather than directing the load at a point, the adhesive distributes it over a larger area, making the adhesive bond more resistant to stresses than a riveted joint.
Next, we are going to test peel strength. Peel tests measure the average force required to fracture the adhesive bond between flexible materials when pulled at a specified angle. These tests are important for describing assemblies where the bond is subjected to peel loads. All of the applied load is concentrated on the leading edge of the adhesive rather than across the entire bonded area. When designing a bonded assembly, these loads should be avoided as much as possible. One method, called the climbing drum peel test, allows for calculation of an adhesive's peel strength independent of the substrate it is bonded to. A bonded assembly is secured in the climbing drum peel fixture in a mechanical properties tester. As the crosshead moves upward, the flexible substrate is wrapped around the drum fixture, peeling it away from its rigid mate. The test can be run using only the flexible substrate, and this value is subtracted from the combined result to provide the peel strength of the adhesive alone.
Now it's time for impact testing. Impact resistance is a measurement of a material's toughness, which is often a main requirement for components operating under dynamic stresses. This property is highly dependent upon the ability of the material to internally move or deform to accommodate the impact. One way to test for impact resistance is to drop a weight from a set height onto a bonded assembly and then record the absorbed energy. Did you know that nowadays, adhesives which in the past had low peel and impact strengths can be toughened with elastomers, resulting in substantial improvement to these properties? Results from short-term tests can help to guide us in the selection of an adhesive, but what about the long-term performance of the bonded assembly? In the real world, bonded parts are exposed to various temperatures, moisture levels, and harsh chemicals, and we do the same to our assembled bonds in the laboratory. Longevity studies and endurance tests are crucial for determining adhesive choice and product shelf life. Packaged adhesives, bonded or cured parts are placed in environmental chambers or immersed in chemical solutions for a specified time period, after which their performance is evaluated.
Threaded fasteners are one of the most important detachable parts used in machinery construction. The functional reliability of threaded assemblies rests on the torque forces applied along its axis, and can be compromised when either tension is relaxed or the part self-loosens. A thread-locking adhesive helps restrict lateral movement by filling the gaps and limiting slip in the thread. One way we test these adhesives is by using straight threaded fasteners like nuts and bolts. A bonded assembly is seated in the torque tester and tested at a defined rotational speed. The initial result recorded is the strength of the first break in the cured adhesive. This is the breakaway value. We are also interested in the remaining resistance of the assembly, which is measured at 90, 180, 270, and 360 degrees. These results are averaged to obtain the prevailing torque strength, which shows how much friction or drag is left to continue turning the nut.
Bottom line, adhesive testing reveals the material properties of an adhesive and shows whether a bonded assembly is suitable for its intended applications. We hope you found this information interesting, and we look forward to hearing from you. Be sure to check out our other videos.